First order ordinary differential homogeneous.
All right, so today we're looking at the reduction to separable form. The reduction to separable form. So now, as we said earlier on, if you have a first order ordinary differential equation and you want to find a way so that we can get rid of the y dx of the function, we have to find a way so that we can get rid of the y dx of the function. But some of the equations are cumbersome to the extent that you have to separate them, you have to reduce them to a separable form so that we can use the method of what? Separation to find the solution to the first order of the differential equation. Now, in certain instances, we have to first find out whether the function is a homogeneous function. If it's homogeneous, then we are saying that both the functions must have what? The same degree. So the m of the function m of xy and n of xy in the differential equation, both of them must have the same degree to qualify to be a homogeneous function. All right. Now, if that is the case, then our first procedure will use that we let y be equal to a certain variable xu. We let y be equal to a certain variable xu, and we find as our first equation, and we find the derivative of the y with respect to the x, which will give us, because this is a product rule, we'll be getting u plus our x du of what? Of the x. Because this is a product rule, so if you do the product rule, this is what you'll be getting to differentiate. So now we can find our dy here as what? X dx plus, sorry, this is our u. So let me write it to a u. So we can find this as what? Our u dx plus what? Because we multiply it also by the x, which we take this into this. So we get our x what? Du as our equation 2. So in the first procedure, when you are given a question and you just find the degree, you can use this idea to solve the particular question, to find the solution to that question. Now let's take a typical question and look at how you go about that. You have x squared plus y squared dx minus 2xy dy is equal to what? 0. X squared minus y squared, x squared plus y squared dx minus 2xy dy is equal to 0. And with this particular question, you have been asked that we should simplify it or find its solution. That is to find a way to get rid of what? The y and the dx over there. So what we do is that, first of all, you have to verify before, to the separable form, we have to find a way to get the x and the y over here with respect to the y. You have to find a way to get the x squared and the y x over here with respect to the x. But this is very cumbersome. So what do? We have to first reduce it to a separable form, like we did in the method of separation of variables. So when we get to that form, then we can just use that method to solve the question. So now what we can do over here is that we have to first check whether the function is what? Homogeneous. The function is homogeneous when both are having the same what? Degree. So now, this is the first function. So the m of xy over here is equal to x squared plus y squared. And the second one, the n of what? Xy over here is equal to our 2x what? Y. Is equal to our 2xy. Now how do we find the homogeneity of these functions? So now we come as what? M of our lambda x, our lambda y, should be equal to what? Should be equal to our lambda x all squared plus our lambda y all squared. And we have our n of our lambda x, our lambda y should be equal to 2 of lambda x, lambda y. So now when you do this, what are you getting? You simplify it, you get what? The lambda square out, x plus y. Or when you simplify this, you get what? The lambda square out, 2x what? Y. So since you're having the lambda square out here, then you can say the degree here is what? Is 2. It's homogeneous with a degree of what? Of 2. And because the degree for both functions are 2, then we can now proceed to solve this function by separating it. So now, what happens is that we use these ideas as the first method we are doing after we do the second method. So with the first method, we said after you prove that they are both homogeneous with the same degree, then let y is equal to xu. And the second one, let your dy be equal to what? U dx plus our x du. U dx plus our x of what? Of du. Alright. So now, if this is so, then what means is that you just take this particular question, we are reducing it to the separable form. So you just take to this particular question. Everywhere you see the y, you put u dx of plus x du. And everywhere you see y, you put what? X over there. Alright, so now our function is what? X squared plus y squared. X squared plus y squared. So y here is what? Xu. So you get what? Your xu all squared. The x minus what is it? We get our 2x. We have y over here. So we put our x over there. And we have our dy. So we put what? Multiplying our u dx plus our x what? Du. Which is equal to what? 0. Please, are you getting it? So the first method, what should be in your head is this. So you now go to the former equation. Everywhere you see y, you put xu. Everywhere you see the y, you put u dx plus what? X du. Alright. So now you simplify this further. And I want to simplify this further. It's very simple. You can go your x squared plus xu squared all the x minus your 2x xu. So now you multiply through with it. So let's multiply here. Let's multiply straight through with that. So 2x times xu times u dx. So what are we getting over here? So you'll be getting what? Minus 2x squared u squared dx. So 2x squared u squared dx. At the same time, multiply the whole of this by this. So we get minus 2x x3 2x cubed u du, which is equal to what? 0. Which is equal to 0. Alright. Now let's take all the x to one part of the equation. Alright, so let's continue from where we just ended. So now what happens is that we can get x squared plus, let's expand this, we get x squared u squared. And because this is x squared u squared, so we can bring it with respect to the x, we can bring it to this part together, and we get minus what? 2s squared u squared, all with respect to what? The x minus 2s cubed u. The u is equal to what? Equal to 0. Alright, so let me clean this side and let's continue from this side. It's a very long procedure. It's a very long procedure of solving. Okay, so now from that place, what do? We can get x squared. So this minus this will give what? Minus x squared u squared into bracket the x minus 2s cubed u. The u is equal to what? The u is equal to what? 0. And here we have to do the separable form, the method of separation. We have to make sure all the u go to one side of the equation and all the x also goes to one side of what? The equation with respect to its particular variable. So now when you do that, what happens is that you can say, you can bring x squared out over here and you have 1 minus what? U squared or the x. You factorize x squared out here minus 2x cubed u, the u is equal to 0. Alright, so now you have this, we get, and divide here by, okay, so let's take this one to the other side of the equation. We get s 1 minus u squared dx, which is equal to 2s cubed u the u. Alright, so now we can divide this side by 1 minus u squared, and you can divide by 2s cubed. And you can divide this also by y minus u squared into bracket 2x what cube. So you realize that we've now gotten to the separable form again of the equation. So now what do we do here? You can simply cancel this out and you can also take this out. So when you do that, you are getting x squared divided by 2x cubed dx, which is equal to u divided by 1 minus u squared what? U. Alright, so now you'll be able to separate the function this way. So what do? We simply have to go back and resolve the question. And when we do that, what are we having over here? When we do this, what are we having? We can rechange everything. But when we have this equation over here, we can rechange everything and we get okay, so here we get this one. I give you 1. S square will go here 1. S square will go here as what? Leaving s. So you have s cubed divided by s squared. So you're leaving s. Alright. So we have 1 over what? 2x dx, which is equal to what? U divided by 1 minus u squared. What? Du. 1 minus u squared du. Alright. So now, from this side, what you could have done over here, is that you could have decided to maintain this side of the equation. We could have decided to maintain some side of the equation to make it very, very simpler for us. Some side of the equation to make it very, very simpler for us. So let's multiply this side by 2, and let's multiply this side also by 2, so that we can get rid of what? These 2 over here, and we multiply these 2 by here, so that when we find the integral over here, we will not have a problem over here. We can just go by the link. Alright, so now we can get 1 over x over here, x, which is equal to what? 2u divided by 1 minus u squared, what? Du. So the moment you get this, then we know that we are now cool with it. Because when you find a derivative here, you get 1. So now we find the integral on both sides of the equation, where this will give us what? Length of what? X, which is equal to, now you find 1 minus u squared, you get minus what? 2u. And that is not what we are having over here. That is not what we are having over here. So now you can introduce a negative value over there. You can decide to introduce a negative value over there. So now when you introduce the negative value over there, then it affects it. So if you introduce the negative value over here, you can also try to introduce a negative value. So when you do that, what you'll be getting is 2u over that. We can bring it back again of the equation. So we get in x divided by minus 2u over 1 minus u squared, what? Du, which is equal to 0. So now I have the negative, which is already affecting that. I getting it. So now when you find the derivative of this, you get minus 2u, and that is the same as what we have on top here. So now when you do that, we have our lane x, which is equal to minus what? Our lane of what? 1 minus u what? Squared, which is equal to what? Our arbitrary constant. And that gives us what? Our arbitrary constant. But because they are all linked, we can take our arbitrary constant as a log value of what? Of the constant. Alright. So now to finish up here, we can have our lane of x minus our lane of what? 1 minus u squared is equal to what? Lane of what? C. So now, what can we see over here? You can make either the subject. So making C the subject, x the subject, because u is a function over here. U is a function of x and y. So you can make x the subject over here. So we get our lane of x, which is equal to our lane C plus our lane of what? 1 minus what? U squared. So our lane of x simple here now becomes, because it's log and log, you can have 1, which is lane into bracket C multiplying 1 minus what? U squared. C multiplying 1 minus what? U squared. So you can have C multiplying 1 minus U squared. Alright, so, okay, this here will be plus because when you introduce the negative here, because of the negative you introduce, here what? It will become plus. So this will be ln plus ln of that. Are you getting it? So the negative will still affect that. Are you getting it? So the middle here will become plus. If you take this, you give -2. So now I have here as plus, and here will be minus. Sorry, right? All right. So now when you do this, you get divide c. It will be division 1 minus u all squared. So you can now take the ln away. You have your x, which is equal to your c, all divided by minus what? Your u squared. Now take note that your u is the same as what? Y on x. So introducing the u, you can have your x as what? C divided by 1 minus what? Y on x, or what? All squared. Y minus what? Your y on x. All what? All squared. And you can further decide to simplify on this. But when you get to this, so you can finally have your x is equal to 1 divided by 1 minus y all on x all squared plus what? So times what? A. So we can just put your A over here, which is your arbitrary constant. Alright. Now let's look at the second method. Let's look at the second method in dealing with what? Your separable, the first order differential equation. All right. So now with the second method of dealing with the first order differential equation, that is the same idea, but with the second method, we want to look at. So the second method, we are taking when you have the y of the x that is equal to a function of what? A certain function of f of x. So we are taking when you have a y of the x which is equal to a certain function of f of x. Yeah, that is when the function is in what? A standard form. When the function is in a standard form but not in a differential form. So this is a standard form, a typical example of a standard form. When you have that, a function in the standard form, but before that, let me just remind you, the standard form was when I did f of x dy dx is equal to what? 0. So you finally can find what? Your standard form as what? Y of what? F of x. You get it? I told you can put the equation in two forms, standard form and what? Your differential form. So now when you have the question in what? A standard form like this, and if your y, your dy dx is equal to the standard form of a function f of x, then it can be expressed and if this your function can be expressed in this form, in the form x on y or y on x, then the equation is homogeneous. So now the first instance we looked at is when we are having the differential form of the equation, and with the differential form we said when they are having the same degree, when you shove it and they are having the same degree, then the equation is homogeneous. But with the standard form, when you solve it and you can express this function in terms of x on y or y on x, then we say the equation is what? Is homogeneous. Now when in this case, with the standard form, you also take that let y be equal to what? X. But this time around we use that you let u be equal to what? Y on x. We take u as the subject of the equation, and we make use of what? The y dx, which is equal to u plus your x du on what? On the x. So these are the two things that you should keep in mind for your differential equation, for your standard form of the differential equation, for a standard form of the differential equation. All right, let's take only one example and look at how we do it. So now we have a standard form equation as x dy dx is equal to y minus x all cubed plus y. And so we are supposed to find a solution to it. You know that still we have to reduce this we have to do this form before we can find the differential solution to it. All right. Okay. So now the focus here is that we should be able to present what? Express the function in form of x or what? Y on x. So this here we can divide here by x, and we can divide the whole of the function here by x. You can divide the whole function by x, 10 by 10. So x will take away x. So you get y prime, which is then equal to 1 on x multiplying y minus x all cubed, which is equal to plus y on what? On x. Now the moment you get the y on x in the equation, then you can represent the y on x by what? Our u. You can represent our y on x by what? By our u. By here too, we can make sure we separate the function over here. So we can have y prime is equal to 1 on x over here. So we can take 1 on x because we have over x here, over x here. So we can factorize 1 on x out, and this function will be x cubed into bracket y on x minus 1 all cubed plus y on x. So now with this function here, we can separate it in this form. So when you separate this function in this form, y cubed minus this, you get this function. And when you do that, you have y, which is equal to s cubed on x, all into bracket, y minus x minus 1, all cubed, plus y on what? Plus y on x. So now if you're able to find a way, deal with your own, this is about your common sense, let me say it that way. Or let me not use the word common, like, but if you're able to find out and locate where you can just put your y on x in the equation, then it makes it what? Homogeneous. And you can easily go ahead and use this idea to solve and find the solution to this first order differential equation. Alright, so here we can have our y prime, which is equal to our x squared y on x minus 1 all cubed plus y on x. So whenever we see y on x over here, we just put our y on x, put u over there. And whenever you see our dy dx, we put u plus x du dx. So now this y dy dx, so we put what? U plus x du on what? Dx will now be equal to x squared into brackets u minus 1 cubed plus what? U minus 1 cubed plus what? Plus u. Alright. So let's continue from this side, so that it doesn't become cumbersome on the board. Alright, so now let's take u prime as the same as what? The u on what? On the x. U prime as the same as what? The derivative of u with respect to x. So now, when you have that, then you'll be getting what? U plus x u prime, which is equal to x squared u minus 1 cubed plus what? Plus u. So now, what you have here is that you can take this or cancel this because you can go and subtract it. So you get what? S u prime, which is equal to what? S squared u minus 1 what? Cube. S squared u minus 1 cube. Now making u prime the subject, what do you get over here? You can have u prime is equal to s squared u minus 1 cube all divided by 1 x. So you divide both sides by x. This will take one of this. So you get u prime is equal to x into bracket u minus 1 all cube. And here you can find a way to separate the function. You can find a way here to separate the function. So do the same as the u on what? The x, which is equal to x u minus 1 what? Cube. So upon separating it, you can have 1 minus u minus 1 cube du equal to x what? The x. So you cross multiply and divide this one also into that. Now when you do this and you find the integral of this side and the integral of this side, you should be able to do this integral. So if you find the integral over here, it is simply what? U minus 1 exponent negative 2, or divided by what? Negative 2. Because 1 over u minus 1 cube is the same as what? U minus 1 exponent what? Negative 3. So if you are finding the derivative over here, this one will already give you 0. So you focus on what? U minus the negative 3. And in order to find the derivative is what? U minus 1 minus 3 plus 1, or divided by what? Minus 3 plus 1, which will give u minus 1 exponent 2 divided by negative 2. So these are things I said you should know already in your basic your high school. So now when you do this differentiation, and this one when you do it, you get half of what? X squared plus an arbitrary constant, which is c. So now because u is a function of x and y, you have to make x the subject of the equation here. So for making x the subject, you can get x squared, which is equal to negative 1, or divided by u minus 1 squared plus what? Your 2c plus, so you multiply both sides by 2 to take this one away. And when you do that, your u becomes highly affected. So since your u here is what? Y on x, you get your x squared as minus 1 divided by y on x minus 1 all squared plus what? Your 2c. So your x can be what? Plus or minus square root of what? Minus 1 divided by y on x minus 1 squared plus 2c. And this will be the solution to the differential equation. I know it looks more difficult or somehow difficult, but always just take time. You can go back and video anytime you want it.